In this video, I want to show the concepts and most important building blocks of the new Istio networking API. So in version 1.0 of Istio, we have the version 3 networking API that also recently has been changed over the last in the last few months. And I personally had some difficulties to wrap my head around all of these concepts and types that we have available to define our traffic management. And I wanted to explain in my own words how that works to hopefully, help somebody else as well. So when it comes to traffic management, this feature of Istio, we have a few types and models available in order to specify how our traffic should be routed inside the service mesh. So how the routing and the traffic all of the magic of Istio or of service meshes actually work is that we deploy some so-called sidecar containers alongside to our main containers that run our applications. So that means each and every instance of particular services in our mesh actually run a so-called proxy. And just to show you how that roughly looks is as follows. Imagine we have a service that could be now a platform defined a service. For example, we typically have Kubernetes, right? So that will be a Kubernetes service, right? So we call this coffee shop. We will have an example of a coffee shop service and some few others later on. And that service, that representation, that visualization here will show us, how to define our workload. So that visualization basically draws a service as a rectangle with a few parts that contained inside of that service. So again, that is just one visualization. We actually do not have a running component as a service somewhere that is, in the case of Kubernetes, just materialized as usually IP tables, right? So, but we define a so-called pod, right? And that pod runs our container. So typically the container that comprises our application. So we can call this, the main container here that runs our application. And alongside we have so-called sidecar container, a proxy container that also runs in our pod. And that is automatically, or at least typically automatically injected by Istio. So that means we do not have to specify that second container. That happens, magically most of the time. And this container is, contained in all of the pods, in all of the instances of our service. So imagine if we had another pod here, then that also would comprise a main container and our proxy container. And these proxies, transparently intercept all the communication that happens inside of our cluster. So for example, if we have incoming traffic, if a client wants to route to our coffee shop instance, then we route to actually the proxy, and the proxy intercepts the traffic, and then it will or it might forward to the main container. And then the main container, our application is called. And also the response goes back through that proxy. All of that happens transparently to our application. That is applied with low-level traffic rules such as IP tables, and we do not have to change our application for that. And similarly, if our application wants to access an external resource, an external system, regardless whether that also runs as part of the cluster, we also go through the proxy. And then the proxy might call another component. And that actually is true for all of the workload that runs inside of our clusters, for all of these pods. And then also Istio actually communicates with all of these proxies that are part of the mesh. So actually we have so-called pilot plane, and we define basically all of the routing, and we gather all the telemetry data through these proxies. So Istio will communicate with all of these proxies also, reconfigure them, how to route our traffic, and also gather the telemetry data here. And this is how all of that is enabled under the hood. Now, in terms of how to define actually the rules, how to do the routing as part of our traffic management. Ultimately, how to tell these Istio these rules that will be materialized as part of and executed by all of these proxies. So first of all, what we want to take into consideration is that we define multiple services, usually as part of the platform. So we have Kubernetes services, for example, for this coffee shop. And we will need to take care what services are known to Istio actually. So let's define a bag of so-called Istio, of Istio services that Istio is aware of. So Istio inside manages a service registry, and everything that is part of that registry can be routed to. Usually that is all of the platform services that we define. So Kubernetes services such as the coffee shop service that we had. Or let's define another service that we will call barista. So assuming the coffee shop application will call the barista application that also runs inside of our cluster. And Istio now, abstracts, first of all of these platform services, but also is aware of these two services, coffee shop and barista, that this is part of our platform. But also, what we will show later, if we would like to access an external system, for example, coffee.com, then this also needs to be part of our service registry. So Istio needs to know about that external system being routed to throughout our mesh. And similarly, what we can also define already is multiple versions. So again, let's say we have two types of services that is defined by Kubernetes, all of these rectangles or our platform, and the service entry that enhances the set of our services. And we might have multiple versions. In the case of Kubernetes, that might be labels that we define for pods. So we have versions such as, version 1 for our coffee shop, and version 1 and version 2, V1 and V2 for our barista service. So actually, we have a single service for barista, but that all of these instances might define, multiple versions. We actually have a subset or two subsets there. And then, how to route to these specific components. So again, first of all, we need to take into account that, all of that is now part of the Istio service registry. First of all, we only consider our platform services. They are part of the registry, coffee shop and barista, and they, ultimately will be used to accept traffic. So how that works is, how can we now define that Istio should actually route traffic to, for example, the coffee shop, or how to route the traffic from our coffee shop application to a specific version, V1 or V2, of a barista application, right? So that happens in, two types that we now want to define: a virtual service and destination rule. So what is that? A virtual service defines a set of traffic routing rules that are applied to a service that is part of that service registry. So everything that is part of the bag that we just drew can be enhanced by a virtual service. Can be actually used to define the traffic routing rules for these virtual service, where they should be actually routed to. That defines all of the traffic routing rules for usually or typically HTTP traffic. Similarly, we have the type of so-called destination rules. Destination rules, they define policies that are applied after that routing has been decided. So after we decided which particular, destination to route to. Policies such as, load balancing policies or TLS, encryption. And then, we can use these two types. We can define, resources, Istio resources for a virtual service and a destination rule that are then taken into account by the proxies that route our traffic to. So if we would again try to visualize that, so assuming we have the example of our coffee shop service that wants to access our barista service. So this is now the platform service, our Kubernetes service that has, a running pod, right? And now the pod wants to, route to something else that wants ultimately to route to barista. So again, that happens via the proxy. And let's say we have an HTTP connection to, well, give us, well, the host barista under port, let's say 8080. So that already works out of the box by the platform, right? In Kubernetes, we can define, we can do a lookup, we can do the HTTP call like that with the name barista that corresponds to the logical service name in Kubernetes, right? And then Kubernetes would do the Kubernetes DNS resolution. We would end up at one instance of the endpoints that is managed here, and then would be routed to a particular instance here. So that means we also have the other platform service, our barista service here defined. And that barista service also now, well, comprises, let's say, multiple parts, right? Because remember, we might have multiple subsets actually. And then, well, all of these parts, we want to route our traffic to these parts, but not just randomly specific parts, but actually, well, our subset that we want to define. For example, version 1 or version 2, defining on some circumstances, right? Otherwise, that would be straightforward. Otherwise, we could just use off the box the Kubernetes service definition, route to it, and done. Or have a so-called virtual service that just defines default roles that always routes to that very subset, the only subset we have, just barista, for example, and route to it. Other than that, actually, we define a virtual service now that comprises all of our routing rules. So our virtual service for the barista service that is part of the Istio defines these routing rules that tell us, well, where to route our traffic to, right? So these specific subsets that we want to have, V1 and V2, are defined in our destination rule. So the destination rules, again, they define policies after the traffic has been routed, and also they specify which subsets we have in our barista service. So let's say we have V1 and V2, and these subsets, well, that is routable in our virtual service then, and these subsets are defined in our platform, for example, by Kubernetes labels that are part of our pods, right? So we have a subset V1 and a subset V2 with the 2 and 1 pods here, and then we route our traffic accordingly. And this is how we could now specify that, first of all, we have 2 subsets that is specified in the destination rule, among other things, with policies. And our virtual service is then being used to route our traffic, depending on, for example, some HTTP criteria, such as header parameters. Now, the reason why I drew that or visualized that in this way and not, for example, drew a box around the barista service is actually because there might not be specifically a one-to-one mapping through from either virtual services or destination rules to platform services, right? Or to Istio services, because actually that could, let's say, be a wildcard. So assuming we define, well, the other coffee shop only comprises one subset. Assuming we define these either virtual services or destination rules for barista, that is possible. But we can also define them for, let's say, all of our services that are part of the platform, for example, for the default namespace in Kubernetes. We could write something like start.default.service.cluster.local, and that then corresponds and is applied to all of the services. For example, if we want to apply some rules or resiliency approaches, that might make sense. So then that is actually being taken into account for, well, all of the services in our service registry. Similarly, and we will cover that or talk about more about that in a moment, we can also define these rules for external services that are now part of our service registry. For example, coffee.com. So that is the reason why I visualize this in that way. What you should take into account is that we define these components for services that are part of the Istio service registry. That is how it works, and the virtual services are used to define our traffic routing rules, and the destination rule is used to, well, first of all, specify the subsets and to apply the policies after the routing has been taking place. Now, how to define these service entries? That is now the type, again, we need to use in order to add external services to our mesh. Because the reason for that is that initially, if we draw our service mesh again, and if we have like our coffee shop service that, let's say, wants to access our barista application. And now the interesting story is if our barista application wants to access something that is, well, outside of a cluster, such as coffee.com. Now, if we would simply invoke coffee.com, that is not possible. This would not work. The Istio proxies, well, do not route anything to the traffic that is, well, not known to the service registry. So that is the reason why, again, we have to define our coffee.com external service to our service registry. And we do so by applying these service entries. So a service entry is a type that we apply and use to add external services to Istio's internal registry. So these services actually might be external to the mesh or internal if we, well, want to enhance services that are not part of a Kubernetes platform, for example. But usually it's being used to, well, route to external services. So what happens is we define a resource for example, coffee.com. That resource is type of, well, service entry. And now actually it works that we route with our proxies to coffee.com to an external service. So that already would work. Additionally, we can, of course, now define virtual services and destination rules for this service entry, so we can further specify and annotate, enhance our traffic rules, for example, add resiliency such as timeouts, right? And these are then, well, used by the proxies. These rules apply to our proxies and are being used to now call the external system. This is the reason why we need the service entries. So now we covered already quite a bit, but one question remains: how to route traffic inside into our cluster, ingress traffic, right? So we have another type that is called gateway. Usually in Kubernetes, we use Kubernetes ingress resources, right? We use ingresses that are deployed to ingress controller and they route traffic into our cluster. In Istio, in this new version, we have gateway resources. So gateways are load balancers that are deployed at the edge of our service mesh, and they are used to route, well, traffic into or out of our cluster, out of our service mesh. So usually they be used as, well, for ingress traffic. So the reason why we use gateways and not ingresses are, well, these gateway resources are only used for, well, layer 4 to layer 6 aware. They're only layer 4 to layer 6 aware for the traffic, and all of the, well, for example, HTTP relating rules, the layer 7 aware rules, are applied actually by virtual services. So this is to align with the networking model of Istio. And another reason for using gateways is actually because with gateways we can, well, Istio is aware of all of the traffic routing rules that we define in virtual services, and also we can, well, capture all of the traffic for our telemetry data, for example. So then it would just work well with everything that is defined in the Istio universe. So how that works is that we define a gateway that is deployed to a so-called gateway controller. And then this gateway actually, well, it is a component that runs, that resides in these controllers and routes our traffic to our cluster, first of all. So we have two versions of that, ingress and egress traffic. For ingress traffic, that is the widely used example, well, we have a gateway that sits at the edge of the cluster. And now, well, we use this to route traffic into our cluster, for example, for one specific IP, right? And then we can now further define rules how to route the traffic to, for example, our coffee shop service, right? How we do that, again, while using virtual services. So virtual services are being used to route the traffic to our service, to a service that resides as part of this the service registry. And now this virtual service will bind to that specific gateway and say, for these circumstances, for these scenarios of the traffic, please route the traffic to the destination, to our service with a potential subset. And this is how we bind ingress traffic to a specific service. So that is, well, similar to the idea of Kubernetes ingresses, uses slightly different model and uses these gateway resources that are again also bound then to the virtual services. So there is a connection that we will model using these APIs to bound ingress traffic to our services. So how does this work for egress traffic, and why? Why will we need these gateways to handle egress traffic? So again, let's draw our service mesh cluster. And let's say once again that our barista application wants to access something outside of our cluster, such as coffee.com. And now, well, again, we need a so-called service entry. We already have that. Otherwise, we have covered that. Otherwise, we wouldn't be able to route the traffic to coffee.com. But in this case, actually what we do, we place a gateway at the edge of the cluster, now as an egress gateway, and we use a virtual service to route the traffic that is supposed to go to coffee.com through that specific gateway. And that will end up at coffee.com. So we define again these traffic routing rules and optional destination rules for example, policies that we want to apply, such as resiliency features or encryption, to route our traffic through that specific gateway. Now, the reason why we should be interested in doing that is in some scenarios it's required that for networking setup purposes we route all of our egress traffic through a specific node, for example. Let's say usually the nodes in our cluster are not able to access a specific network, and we have to route through through specific components. So that means that all of our egress traffic actually should happen or must happen through a specific node. And this is where these gateways come into play, because the gateways are actually then are deployed to actually running workloads to a specific node here, and all of our traffic is then routed through these gateways. Because otherwise, in a simpler example we had before, if we just define a service entry and then, actually the proxy of a specific instance directly routes to coffee.com through on that node wherever that runs, and it doesn't go through another component. In this case, for the gateways, that is actually the case. We route through a specific nodes. And again, this is the reason for that might be a networking setup, so we can handle this. Also, then we have a more synchronous model to the ingress traffic as well. But this is only needed in these cases. Otherwise, a service entry is sufficient. So again, how to route our traffic inside of the service registry. We now covered all of the services that are part of the platform, such as coffee shop and barista, that we can route to. And also we covered why we need a service entry, for example, for coffee.com, in order to make that accessible. Now, virtual services can be defined for our rectangles as well as service entries here. So we can define virtual services for the routing as well as destination rules for all of these services that are part of our service registry, as well as wildcards thereof. So if we say we have a wildcard for example, all of the Kubernetes services in a specific namespace, or for all of the subdomains for coffee.com, we can define virtual services and destination rules for these as well. And all of the workloads that are actually routable in our Istio service mesh are, well, all of the rectangles, all of the platform services, of course, and all of the specific, well, versions and specific subsets. So we can always directly route to service instances of Barista, for example, and this would correspond to a default routing rule to Barista. Or we can say for these specific conditions, or for all of the traffic, we want to route to a specific destination, such as subset this and that, such a subset version 1 or version 2, for example, that corresponds to these labels. These are also routable in our service mesh that is part of the service registry. So this is roughly what building blocks, what components and types we have in the new Istio networking model. I advise you to have a look at the documentation as well as the reference. I hope this helped you understanding or visualizing a little bit what components are there, roughly what the motivations are and the concepts, and what typical use cases are to apply the typical scenarios that we have in enterprise microservice setups. So I hope this helped you in understanding a little bit how the networking API works. Thank you for watching.